The circle that I've drawn here is a unit circle. The meaning of a unit circle is it's a circle whose radius is 1. Talking about this distance being 1. But that also implies that the length of the red vector is also 1. Now you can create a triangle with your angle. So if we have a theta here, and let's say it's 45 degrees. I said last time that you could create a triangle from this situation by dropping a leg down vertically to the x-axis. And then also we can create a base for that triangle. And so the height of the blue, we said before, was going to be called the sine of the angle theta. The width there of your triangle is known as the cosine of the angle, as long as we're talking about a unit circle where the hypotenuse is 1. So what this implies is that using Pythagorean theorem, we can find an identity, it's called. A trigonometric identity. The way it works, Pythagorean theorem, is that you take a leg squared plus another leg squared and have that equal to the hypotenuse squared, right? Let's let the sine of theta be A. And let's let the cosine of theta be B. Then we have this identity. Sine theta squared plus cos theta squared equals our hypotenuse, which is 1 squared. Now oftentimes in trig, those squares, they get put here. It's just kind of a notation thing, but it means the same thing as sine of theta squared if you write sine squared theta. So we have sine squared theta plus cosine squared theta is 1. That's a useful identity. We can also start with the identity that we have so far and create a new one. Here's how it would work. Start with sine squared theta plus cos squared theta equals 1. And then what you do is you divide all terms by an expression of your choice. So what would be a good choice here? We could divide by sine squared theta. Okay, so what would that look like? Sine squared theta plus cos squared theta equals 1, and then divide him by sine squared theta. Divide him by sine squared theta. And do the same thing to this guy. Okay, now this would become just a 1 because it's something divided by itself. Here we could simplify a little bit and put the cosine theta over sine theta in parentheses with the square on the outside for a minute. Over here, what we could do is do the same thing. Bring the square out. We always have these identities from our past that 1 over sine theta was equal to what we called cosecant theta. We also have 1 over cos theta is going to be the secant of theta. And then we also have one more that cosine theta over sine theta was cotangent of theta. So we want to use those now to find new identities. So that would make this 1 plus cotangent theta squared equals cosecant theta squared. And then we could put it into his simpler form that looks like this. And there's one more that could be made as well. This time I'm going to divide all terms by cosine squared theta. Let's divide all terms by cosine squared theta. Okay, so this guy's going to be tan squared theta. This is going to be a 1. And this one is going to be what we call secant squared theta. That's the third identity that we could use.